My dear students and my viewers, to my channel Mathematics Made Easy. And today we are on day 4 of our 10 days of trigonometry. This is Ms. Ruchika welcoming you to today's session, and let's dive into the video. I hope you have seen my previous videos on 10 days of trigonometry. I will provide the link in the description box for day 1, 2 and 3. So let's get into today's session. So the problems for today are very basic. They are very simple. Today on day 4 of our trigonometry session, the problems that we are taking are the following. So you see here 6 parts, small parts to this question, and this is a part of grade 10 or class 10 trigonometry. Now these are very basic questions where out of the 6 trigonometric ratios, you will be given any one in each part and you will have to find the remaining 5 trigonometric ratios. So out of these 6 parts, we'll be doing 3 parts only in today's session. As you see, some of them are the same trigonometric ratios. So we are going to pick up tan, we are going to pick up cos, and we are going to pick up sine. So these three we'll be picking up. So question 7, 8 and 12 will be solving together in this session, and then you can try very similar problems, same ratios. You see tan, sine and cos. That is question 7. Question 9, 10 and 11. So you can try these problems yourself in a similar manner. So let's see what are the steps in solving. Okay, so before we solve those problems for today, I'm going to recall here very quickly for you the shortcut that we will use for solving this question. This shortcut is a basic shortcut for solving any question that comes on the trigonometric ratios. So this rule is called SOH. So here S represents the first alphabet S, C, T. This represents the basic trigonometric ratios of sine, cos and tan, and O, H and A represents the notation for the sides of the right triangle. So here you see the right triangle, one angle is 90, and the side which is very close to this 90 or closest is the adjacent, the one which is opposite to the angle that we are talking about. So usually we take for the trigonometry an acute angle. So measure is less than 90, so that is this angle theta that we are taking here. The side opposite to this theta is the opposite, the one which is closer is adjacent, and the longest side is hypotenuse. So this is all what you know, just quickly revising. And how do you identify hypotenuse in a right triangle? You take the side opposite to the 90-degree. So it's always the longest side, remember that. Okay, now how does this SOH TOA help us for trigonometric ratio? How does it help us? So let's recall. So S is for sine, I told you. So if you have to find the sine of theta of the acute angle that we are going to be having in the right angle triangle, remember we are talking about right triangle trigonometry. So one of the angles in that triangle where you have to find the trigonometric ratio has to be 90, like this. Only then you can have these 6 trigonometric ratios well defined. So sine, cos, tan, right now we are talking about acute angle theta. So sine, how you remember the formula, is opposite divided by hypotenuse. Similarly, cos or c, ka, it comes from ka, CAH. So cosine is adjacent divided by hypotenuse, and last but not the least, tangent is opposite divided by adjacent. So these are the 3 basic trigonometric ratio: sine, cos, tan, and the remaining 3, cosecant, secant and cot, you can find using the basic 3 ratios. So these 3 actually together are called, if you remember, reciprocal trigonometric ratios. So I hope you recall that cosecant, now I'm talking about theta angle, is 1 over sine theta. So cosecant is the reciprocal of sine. Similarly, secant is the reciprocal of cos. And lastly, cot theta is the reciprocal of tan theta. So these three are the reciprocal ratios. So if you are able to find using SOH TOA the three ratios here, then just take the reciprocal. Reciprocal means what? Let's recall that as well. Reciprocal means you flip the numerator and denominator, right? So if you are given in a question, for example, sine of theta as 3 divided by 4, okay, then what will be cosecant? Just flip the numerator denominator, so that will come out to be 4 over 3. Similarly, you can do the reciprocal ratio for cos and tan as secant and cosecant. Okay, so now we've recalled everything that we need. We are ready and geared up with the formulas for the question. So let's now solve the three parts. Okay, so let's solve first question 7 and 8 in this slide. So I'm going to begin with question 7, and we are going to use SOH TOA that we learned in the last slide. So here let's see which is given. So we are given tan ratio and we need to find all the remaining 5 trigonometric functions. Okay, now we are talking about right triangle trigonometry. So let's draw a right triangle first. This is my 90-degree and I'm talking about acute angle A here, right? So how can I name this? For example, this is my angle A, then let's name this B and C. Okay, so this is my right angle triangle. And here if you see, A and B are given to be acute angles. So that means I have to change this. So if you do the same mistake, you'll have to correct it. So this can be C and B will be this angle. Why? Because it is given in the question that A and B are acute. So I'm talking about right now here angle A, and even B now here is acute. So this is a well-defined right angle triangle. Okay, so which ratio will we use? Sine, cos or tan? Definitely tan because that's given. So I'm using 2A. That tells you that tan of A is equal to O divided by A, means opposite to angle A divided by adjacent to angle A. Now remember, this is an important point because I'm talking about tan of A, so the opposite and the adjacent side would be defined with respect to this angle A. Okay, so let's see what is opposite to A. Let me change color. So this is angle A. Opposite is this side, so it is BC divided by what is the adjacent? Adjacent means closest. So that is AC, right? And definitely because hypotenuse is the longest and opposite to right angle. So this is my hypotenuse, correct? Now this hypotenuse, this is adjacent and this is very nice. So this value is given to you. How much? 8 over 15. Now this is a trigonometric ratio. Let me write this again. So if it is a trigonometric ratio, what does that mean? It is the simplest ratio. So that doesn't mean when I compare this value, it will not be right to say that the BC side length is 8 and AC side length is 15. No, this is a ratio. So this is the simplest ratio. So it can be 8K and 15K. I hope you understand this. Okay. Any which ways, that's a different thing. Now you know BC is 8K, AC is 15K. Now it's a right triangle. So which theorem holds true in a right triangle? I hope you can recall about Pythagoras, the famous mathematician, and behind him we have this Pythagoras theorem, which is true for a right angle triangle. So what does it say? If you have any two sides given, you can find the third side using Pythagoras theorem. So hypotenuse is the longest, so AB square is equal to BC square plus AC square. That's your hypotenuse theorem. So let's put in values. 8 square plus 15 square. Simplify. This is 64 plus 225. That comes out to be 829. So this is AB square. But what do we need? We need length AB. We need the hypotenuse because I have to define all my other trigonometric ratios using this. So if AB square is 289, AB will be its square root, right? And we are talking about length, so we'll ignore the negative and just take the positive. So this is 17 units, and definitely it is more than 8 and 15. So well defined, our answer is correct. So we got hypotenuse as 17 units. So now you have all sides, you have adjacent, you have opposite, Let's write that also. So I'm now writing for the other two. And remember, these hypotenuse, opposite, adjacent are defined with respect to angle A. If I change B, then the opposite and adjacent will interchange. Okay, so we are writing with respect to the angle which is given. So opposite to this is BC length, which is 8, and adjacent to angle A is AC length, which is 15. Okay, good enough. We got all the sides. Now that we have all the sides, we are ready to find all other trigonometric ratios. So let's now come up to back to our SOH. I'm just going to put a little margins here. So tells you that sine of angle A is opposite to angle A divided by hypotenuse to angle A. So how much is opposite? 8. How much is hypotenuse? 17. So that's your sine. Okay, we are done with sine. We already had tan. Let's do for cos. So cos will be adjacent divided by hypotenuse. So now I'm directly writing 15 over 17. Correct? Now we're just left for the remaining three, which are reciprocal. So easy to say that we don't need to write the formula again. Just directly we can say that cosecant of A, which is the opposite of sine, will be opposite of this. So 17 over 8. Similarly, secant of A, which is the opposite of cos, will be reciprocal of 15 over 17. So it will be 17 over 15. And last but not the least, the reciprocal of tan. So it will be cot A, which is reciprocal of 8 over 15. So we just flip the numerator denominator. So 15 over 8. So do we have all trigonometric ratios ready? Let's check. Tan was given number 1, its opposite cot, we got 2. 3 sine we got as this. Reciprocal cosecant we got 5, cos we got 6, secant we got. So all 6 trigonometric ratios are done. That's how you solve question 7. Okay, so now I'm providing you the answer key. So we already discussed question 7. You can check your answers. So we've got as a final answer these 6 trigonometric ratios: sine, cos, tan, secant, cosecant, cot. So same answers. In a similar way, you do question 8. The only difference here is that instead of tan, as we got in 7, cos is given. So accordingly, you will just use the same thing. So TOA along with Pythagoras theorem to find the third side, and then plug in the values and get your answer. So the sine, cos, tan, secant, cosecant, cot for question 8 would be like this. Please check your answers. Again, now I'm providing you the answer key for question 9 and 10. And one point which I would like to reiterate here, which is different from the previous slide, is that here, if you read properly in these two parts, the angle which we are considering is angle B. So when you are defining your opposite and adjacent side, this time you are going to define it with angle B. So this side BC would become the adjacent to angle B, and AC is hypotenuse, so we're not going to fiddle with that. It remains same, whereas AC in this case becomes opposite to angle B. So this is how your sides will change. However, the Pythagoras theorem, finding the third side and using SOH will be the same thing for both of these questions. So just check your answers. For all the 6 trigonometric ratios, it will come out to be this. And before we move on to the next slide, one fact that I would like to remind you, maybe some of you have forgotten, is about rationalizing the denominator. So whenever you have a radical sign, recall that like this. If you find your sine of B, it comes out to be 3 divided by square root of 10. So whenever you have a radical sign like this in the denominator, you try to get rid of that by multiplying with the same factor. So what do? 3 divided by square root of 10, you multiply again numerator denominator both, because when you do that to both sides up and down, it will not change the answer. So the factor will be same. So when you do that, the benefit is that the numerator becomes 3 square root 10. However, in the denominator, because two radicals square root 10 and 10 are multiplied, so I hope you know that when you multiply that, it is same as square root of 100. 10 and 10 gets multiplied together, and that removes the radical by giving you 10. Correct? So that is how you do the rationalization. So we have done that rationalization for sine here in this question, even for cos B in question 9, and similarly we've done the same thing for tan B and secant B. So if you look at these values, don't get confused how you are getting it. The concept is rationalizing the denominator. So that completes question 9 and 10. That brings us to the end of today's session. This was a very basic trigonometric ratio problems that we discussed. The basic factor being the TOA concept that you are using for finding the sixth trigonometric ratio, and also your Pythagoras theorem, which is valid for a right triangle. So thank you for watching this video. I hope you find it useful, and it clears your doubts regarding to finding the trigonometric ratios, the six trigonometry ratios for right triangles. Until then, this is Ms. Ruchika signing off from the session. Don't forget to like, share and subscribe if you like the video, and share it with your friends of similar classes. Bye bye.